Now, we looked at multiplying two monomials, and I thank you for joining me on this next video. I want to look at now what happens if I multiply a monomial times a polynomial. There's only one word here that we need to know to take care of this. And that word is distribute. We've done this before. We know how to distribute. And that's what you do when you multiply a single term, monomial, times a larger polynomial. Okay. For example, if I have 8x times 5x to the fifth minus 7y. This isn't new to us. So I what? That's all I did right there. Distribute, man. Come on. Distribute. What do you get there when you multiply? Look, I'm going to help you out. Look, there's a big fat thumb right there.
That's what I was going to say, but I wasn't sure.
Even if you're wrong, I'll just berate you, and then I'll build you back up. That's what I do. It's like those McDonald's that they end up tearing down. Just put a new one in its place. You are the old version of a McDonald's. I'm going to level you and build you back up the way you're supposed to be.
40x6.
40x6? Is that a football play?
40x to the 6th.
Oh, x to the 6th. Oh, I'm sorry. Lo siento mucho. Yes, because 8 times 5 is 40. How many factors of x do you have here? I've got 1 and I've got 5. That gives me 6, right? When you understand what exponents mean, it's not like, oh, I forgot the property. It's, you know that exponents is how many factors of that guy you have. So I've got 1 and 5 factors, 6 factors altogether. Finish distributing. Remember, don't fake the funk on a nasty dunk. Minus 56 because 8 times 7 is 56, not 54 or any other kind of whatever crazy number you come up with. But you said just xy? Yeah. I've got one factor of x, one factor of y, so I'm just going to write xy. What do you guys think? How would you like to see that on a quiz? In case you guys in YouTube land can't hear that, they are all excited. They can't wait to take a quiz. You laugh? You like quizzes, especially when there are fractions. And especially when all you have to do is multiply the fractions. Well, let's make things a little bit more challenging, shall we? Now remember, I do this because I love you. Okay? So here I've got negative 11x to the 5th y to the 7th times that huge polynomial. Are you going to freak out? No. Oh yeah, oh, one person is. Fortunately, there aren't that many people here today, so you only account for 9% of the population. Don't you love how I just throw out the percentages like that? Yay, math! It never goes away. I can't wait for it to work today. So let's distribute negative 11 times 8. Come on now, I really hate to wait.
Negative 88, x to the 7th, y to the 16th, so to the 16th.
X to the 7th, y to the 16th. Greg, bringing it strong today. I said you're bringing it strong today. That's an attaboy, an excellent, good job. I'm trying to learn from my math lab. Let me pull out a card. Oh, great. Keep distributing. What do we get?
Plus 66, x to the 6th, y to the 97th.
You know what? You are taking complete ownership of this problem, so go ahead and finish this.
Minus 99, x to the 9th, y to the 8th.
Minus 99, x to the 9th, y to the 8th. What do you think?
Yes.
Yes?
Easy.
Es muy fácil. Well, this is easy as long as we can do two things. Multiply and add. That's all I'm requiring you to do pretty much on this next test. Can you multiply and can you add? Of course, multiplication also takes into division, and addition includes subtraction. So as long as you guys can do that, we're in good shape. Uno más? Sí. What's your problem?
Wouldn't we combine those?
Combine these guys. What do we combine? We
The
combine
X
what?
one.
We combine what?
The X and
No, like terms.
Okay.
What does it mean to be a like term? It's a good question.
Does that have the same base?
They have to have the same base, the same variables, but the exponents must be matching, right?
Which is the negative 88 plus 66.
Do these exponents for the x's match up
No.
with any of these guys? So in order to be a like term to this, you must also have x to the 7th, y to the 16th. But do you see that out here? No. So you're going to be done.
Okay.
Are you with me on that? Because if you try to combine these guys into something else, then my question to you is going back to the first problem we did, why didn't you combine these?
Oh, okay. Alright.
We don't combine these guys because if you combine x to the 3rd and x squared, that's like you saying, all right, well, I've got 5 gallons of something and I've got 24 square feet of something else. Do you combine gallons and square feet? Those units don't match up. They're not the same, they don't have the same degree, right? Cubic units doesn't match up with square units. Do you all agree? That's what we have to concern ourselves with like terms. And I'll tell you this, if you do not understand like terms, if you refuse to learn like terms, I will tell you what your grade will be at the end of the semester. I think you already know the letter. Yeah, sure. It will be a bad grade. But I'm serious. If you guys do not know how to combine like terms by the end of the semester, you will fail this class. This is not a threat. It's a promise. All right. So going back to Tasha's, fetish with fractions. Now we have to multiply this out. Me? You're the one who wanted this.
40 over 12.
40 over 12. Now I can do it, but here's what would probably be better for us. You know you're going to multiply and distribute this, right? Well, let's see if there's simplifying that can be done with fractions. What you may want to do is kind of sketch that out on the side. Like if I do this on the side, I've got 5 over 4 times 8 over 3. Is there any kind of reducing that can go along with 5 over 4?
The
What?
8 and the 4.
4 is reduced into this guy to give me a 1 and give me a 2. Do you all agree? So what do we get?
10 over 3.
10 over 12. Can I stop you for a second? So you wouldn't actually add the fractions in the parentheses first?
You know what? I can't just add these fractions in the parentheses because they're coefficients connected to the variable pieces. So the only way you could add the fractions is if you had like terms, if the variable components matched up exactly.
Oh,
But since they don't, I can't combine those guys. That's a good question.
thank you.
Now, that's 10/3. How much x do we have? Let's get back to the easy part, right?
Do you have to make it, can you just go through it, or do you have to simplify it?
Do I have to simplify the fraction?
Yeah. Oh, yes. Well, I mean, like, what if you just, like, go through it, like...
If you go through it first, you just say 40 over 12 and blah, blah, blah.
Yeah.
If you leave 40 over 12, you will lose points because you always simplify.
Okay.
Always simplify. Okay? Total de tiempo. Did I say that right?
No.
I didn't.
What'd you say?
Said total de tiempo?
You can't see like that.
Oh, that just sounds stupid, right? Sounds like I learned Spanish in some, backwoods high school in Tennessee.
11th power?
How would you say always then? Oh, siempre.
Simply.
Why did I not think about that? Oh, that's right. I didn't grow up speaking Spanish.
Wow.
Plus 3/5.
3/5?
Yeah.
Well, let's see. I'm multiplying 5 over 4 times 12 over 25. I'm going to reduce the 5s.
1 and 12 off.
Reduce 4. Oh, sweet. That's nice. Those are easy fractions, right? Anybody else get 3/5? You with me on that? How much x do you have?
8.
And what else?
A3. B4.
A to the third and b to the fourth, right? Because these guys don't have the same base, do they? So you cannot add those exponents. Tricky, tricky. Any questions about this problem? Huh? Tough.
I mean, I got it, but.
You're saying for everybody else it could be tough.